Okay, good afternoon, guys. Today we're going to be talking about absolute maximums and absolute minimums on a closed interval. And we'll be working with continuous functions. So if we do have a continuous function, then we will have an absolute max or an absolute min. So let me restate that, because that is one thing that I do want you to list as your keynote, is that an absolute max and an absolute min will occur if we're talking about a function that's continuous on a closed interval. So if you look at this function, we can see, just using layman's terms, we can see that this has no holes, no jumps. It's a smooth curve, so this is going to be a continuous function, and it has a closed interval. Let's just say this is from 0 to 7. So we know it's closed because we don't have any open holes here. So we know it's a closed interval from 0 to 7. And it's a continuous function, and we can see that it has an absolute max and an absolute min. So what we're going to be talking about today with absolute max, now you can see there is a difference between an absolute max and a relative max. So that is not always the case. You're going to see cases where the relative max is also the absolute max. But in this particular case, you can look here you have and I wrote this wrong, so I have to correct that. This is not your absolute min. So let's erase that. Here you have an absolute min. So you have an absolute min that's also a relative min. So make sure that you do make those distinctions, that sometimes your absolute and your relative minimums are going to be the same. But if you look in this case, you have a relative max that is not your absolute max. So that's not the same situation. But if you look at this next example, you have your absolute max, and so your absolute max is also a relative max, and then your absolute min is also your relative min here. And so if you look here, you have a critical value at this particular number, and we know we have a critical value at, let's just say, x is equal to 2, because our derivative is going to be 0. So anywhere the first derivative is equal to 0, we know that that's going to be a critical value. So we also have a critical value here. Let's just say this is 5, because the derivative here is 0. So that's another key point that you're going to need to write down, that an absolute max can occur when your derivative is equal to 0 or undefined, right? Or your absolute max can occur at your endpoints. So let's kind of look at an example and go into a little deeper discussion with these problems. So I'm going to do an example here. So let's just say if I had f of x is equal to 2x squared minus let's just say 12x, and we want to look at this interval from 0 to 5. All right, so another key thing here is that this is a continuous function. It's a second degree polynomial, and we do have a closed interval from 0 to 5, so I'm guaranteed to have an absolute max or an absolute minimum. That's guaranteed, because this is a continuous function on a closed interval. So what I am going to have to do is, in order to determine where my absolute max or absolute mins are going to occur, it's either going to occur when I have a relative max or relative min, or it's going to occur at the endpoints. That's where my absolute max and my absolute mins will always occur. So that's another key point that you need to make sure you understand, that when I get ready to test my values, I'm going to be testing whatever x value that I have a relative max or relative min, or the endpoints, which will always be given. So the first thing that I'm going to do is I'm going to find the derivative of f to determine if I have a relative max or a relative min. So I have f prime of x is equal to 4x minus 12. And remember, in order to determine if I have a relative max or a relative min, I first need to find my critical values. We have two possible categories that the critical values can fall in. Either a critical value can be when the derivative is equal to 0 or when the derivative is undefined. Well, our derivative for this polynomial function is a linear function, which is always defined. And so we'll find, we know that we don't have the case where the derivative is going to be undefined. We just need to check to see when the derivative is equal to 0. So let's go ahead and set the derivative equal to 0 and solve for the independent variable x. All right, so that means I need to add 12 to both sides. So I get 4x is equal to 12. Then I'm going to divide both sides by 4. So x is equal to 3. So this is a possible candidate, but the only way that we can determine if the absolute max or the absolute min is going to be at x is equal to 3, we first need to check to see if it's going to be a relative max or a relative min. If it's not a relative max or a relative min, then the only thing I need to do is check my endpoints, and because the absolute max and the absolute min is going to happen at the endpoints if I don't have relative max or relative mins. That's another key point that you need to be writing down, that if I do not have an absolute relative max or a relative min, then that means that my absolute max and absolute min is going to have to occur at the endpoints. And this is for a continuous function on a closed interval. So here we go. I am going to test values to the left of 3 and to the right of 3. Now keep in mind, my interval is only defined from 0 to 5. So anything that's outside of 0 or 5, I can't use that as points that I'm going to test with, because the function is not defined. I'm not looking at the function outside of those values. So for this function, we've restricted the domain only from 0 to 5. So I'm going to use 1. So let's go ahead and use 1. And so if I plug in 1, then that's going to give me what? And I remember I'm plugging 1 back into the derivative because in order to determine a relative max or a min, I want to see when the derivative is changing from either positive to negative or negative to positive. So I plug in 1, and what do I get? I'm going to get 4 times 1, which is 4 minus 12. So that's a negative number because that's going to give me a negative 8. And then when I plug in the value of 4 to the, that's the value to the right of 3, I'm going to get 4 times 4, which is 16 minus 12. So that's going to be a positive 4. So I know I have a relative min at x is equal to 3, and f has the function f of x, right, has a relative max at x is equal to 3 because we know f prime is going to change from negative to positive. So I have a relative min. So that means that this is a possible candidate. This could actually be an absolute min, right? Because you have a relative minimum, so that's a possible candidate. So now we need to test all of our possible candidates for the absolute max. So we have x and f of x, and we know that f of x is equal to 2x minus 12x. Because we're trying to find the absolute maximum or the absolute minimum of the graph of f of x. So this is what we're trying to find the absolute max and absolute min of. So let's plug in those values and see what the outcome is going to be. So I have 0, 3, and 5. So 0, 3, and 5. So I'm going to plug in 0. When I plug in 0, well, I'm going to get 0. And a quick way to see that is because every term has an x in it, so you know you're going to get 0. And then I'm going to plug in 3. So So that's going to be a little more work, but not much. That's going to be 2 times 3 squared minus 12 times 3. So that's going to equal 2 times 9, which is 18, minus 36. So that's going to give us a negative 18. I'm sorry. And then plug in 5. We get a little bigger values going on here. We got 2 times 5 squared minus 12 times 5. And so when I do 2 times 5 squared, well, 5 squared is just 25 times 2. So that's going to be 50. And then 12 times 5 is going to be 60. So 60 minus, 50 minus 5. 50 minus 60 is going to be negative 10. So now we need to go through these values to see what's the smallest and what's the largest. Well, we have 2 negative numbers, so we can see that the largest number is going to be 0, and then our smaller number is going to be negative 18. So in this particular case, our maximum actually occurs when x is equal to 0, and then our minimum is going to occur when x is equal to negative 18. When x is equal to 3. So this is going to be my absolute. Let's just write it on this side. This is my absolute max. And then this is going to be my absolute min. So just to recap some things, you have to, if you're finding an absolute max or absolute minimum for a continuous function on a closed interval, you're going to have to always test your endpoints, because your absolute max can possibly occur at your endpoints, or it could possibly occur when you have a relative max or a relative min. So if you have a relative min, that can also be your absolute min, and if you have a relative max, that can also be your absolute max. I do appreciate the time that you took out to listen to this video. Hopefully this will help you guys understand the objective is finding the absolute max and absolute min. Thank you and have a great day.